Hi, in this video we are going to study basics of text processing which includes tokenization, staining, lemmatization and POS tagging. So as we want machine to understand the natural language or human languages, we have to divide that content. Means for example, if we consider the document as input, then we have to divide that document which contains the text into either sentences, subwords, words, or paragraph so that we can assign meaning to each of these part and machine is able to understand the content. That's why tokenization is important phase in NLP. Tokenization is text pre-processing technique used to split data into smaller units, and these smaller units can be paragraphs, sentences, words that can be more easily assigned meaning. We have to convert data into understandable bits of data that a program can work with. Example of tokenization is it can be any sentence, and after the tokenization we get the tokens as a separate words of that sentence. Now, why the tokenization is important? It is very important step in NLP because we extract the meaning of text by interpreting and analyzing the words present in the text. That's why before processing any natural language, we have to identify the words as well as punctuations. Why we have to consider the punctuations? The example of that can be $50 has different meaning than 50%. That's why we have to treat punctuations as a separate token as it holds the meaning. Next, types of tokenization. There are three types: word tokenization, character tokenization, subword tokenization. So based on the application, we have to choose type of tokenization or tokens we want. Maybe it can be word, we can need separate character as a token, or we may need subwords as a different token based on the application. Now, which tools are used for tokenization? First one, white space tokenization. Second, NLTK library is there which provides us different tokenizers to create tokens. Then text blob is there, Spacy, Gensim, Keras. These are the libraries which provides us tokenizers to create tokens from the for the text. First one, white space tokenization. This is the simplest way to create tokens. It uses white space to separate tokens from one another. It is available in Python with split function. Split function is available on all strings object instances as well as on the string built-in class itself. We can change the separator which differentiates the different tokens. Next, NLTK library. So NLTK library provides different tokenizers like word tokenizer, sentence tokenizer, tree bank word tokenizer, word punch tokenizer, tweet tokenizer, and MWE tokenizers. Based on the type of tokens we are going to need for the application, we have to choose the different tokenizers. So to use any tokenizer, first we have to import the NLTK library, and from NLTK tokenize we have to import different tokenizers. First we will see the word tokenizer and sentence tokenizer. To get tokens as a separate word, we have to pass any sentence or we have to pass our data to the word tokenizer function, and we get separate words as a tokens. Then second, sentence tokenizer, we have to pass our data to send tokenize function and we get separate sentences as a tokens here. Then next, punctuation based tokenizer. This tokenizer splits the sentences into words based on white space and the punctuations. So we get punctuations as a separate tokens here. Then next, tree bank word tokenizer. So this tokenizer has variety of common rules for English word tokenization. Here in this tokenizer, word or subwords can be recognized as separate words. For example, don't is a tokenized as do and not. So we can assign meaning to these different tokens. That is possible in tree bank word tokenizer, which is not possible in previous tokenizer. So that is the difference. Then next, tweet tokenizer. When we want to apply tokenization in text data like tweets, the tokenizer mentioned above can't produce practical tokens. Through this issue, NLTK has a rule-based tokenizer special for tweets. We can split emojis into different words if we need them for tasks like sentiment analysis. So here we can see that for the sentence, don't take cryptocurrency advice from people on Twitter, and two emojis are there. So after applying tweet tokenizer, we may get those emojis as separate tokens, and we can assign or we can get meaning from that emojis, which are the separate tokens. That is useful in sentiment analysis. It is not possible in the case of previous tokenizers. So tweet tokenizer is specially for the data like which contains the conversations and emojis. Next, MWE tokenizer. So an MW means multi-word expression tokenizer. So where we want different words as a single token, then we have to pass those words to MWE function so that we can get it as single token. For example, in the following sentence you can see that hope is the only thing stronger than a fear. Hunger Games hash hope. So here we want Hunger Games should be treated as single token, so we have to pass these two words to a function add MWE. In second case you can see that function tokenizer.add MWE, where we have passed two words hunger and games, and in the result after applying the tokenizer we may get Hunger Games as a single token. So this is available in MWE tokenizer only.